post videos on YouTube as I've been doing before. This is just for your benefit, so you guys can go back and look at it if you need to. Okay. So let's go. We're gonna do 5.7 Pythagorean Theorem. This is everybody's favorite. Let's see. Carter. Who's Carter? Where are you, Carter? You're Carter? All right. Tell me what the Pythagorean theorem is.
That a squared plus b squared equals c squared.
Okay, so a squared plus b squared is equal to c squared, right? Give me an example that you know that three numbers work for the Pythagorean theorem. Anybody? You guys didn't do this in algebra? You guys did this in algebra, right?
Mm-hmm.
Right? Right? What if a is equal to 3, b is equal to 4? Does this work? What is c? 5. Right? 9 plus 16. Right? C squared, a squared, b squared, 25. In algebra, you were taught this is plus or minus 5. But since we are in geometry and we don't deal with negative lengths, right? We're in geometry, so we're not going to worry about the negative. C is equal to 5, right? So these are called what? What do we call these things? These are called Pythagorean triplets. There are 3 integers that satisfy Pythagorean theorem. Okay. What if b was equal to 3? Can anyone tell me what c is? How would I find c? Sophie. How would I find c?
Do 3 squared plus 3 squared.
Okay, so I'm going to have 9 here, right? What am I going to have for the total? 18. Therefore, c is going to be the square root of 18. Right? In algebra, you learn that you can, this is not how you want to write it, right? How do I want to write this? What's the square root of 9? 3. 3 root 2. 3 root 2, right? Okay, all right. So this is stuff that you learn in algebra, and really, I don't think we're going to go any further than that. So the only thing that we're going to talk about is that in a triangle, the Pythagorean theorem works when? If I have a Pythagorean theorem that works on a triangle, what does that mean? The triangle is a right triangle, okay? So the Pythagorean theorem only works in a right triangle, right? Okay, so this has to be a right triangle for a squared plus b squared is equal to c squared. What if I kept a and b legs the same length, but I move this angle out like this to be an obtuse angle now? And what's going to be the relationship between c squared, a squared, and b squared? Because I kept a and b the lengths the same, right? I just moved what was here. Okay, well, actually, I knew I did. It's going to be about here, right? Right here. Okay. So what happened to c? Did c get larger or smaller? Or longer or shorter? What happened to c? It became longer, right? Because what was here and I moved it out over here, right? So now, since this stayed the same and this got bigger, you can go like that. if it's an obtuse triangle, right? The opposite of this would be what? If I had an triangle that I started from here, okay, this was my right triangle, and now I move it over here like this to make this an acute angle, and this is C, A, and B. Now what's the relationship? Which one's larger? It's the other way around, right? The C is shorter now. This, again, A and B stayed the same. We're gonna have this. Okay. So, Pythagorean theorem says, if we are a 90-degree triangle, a right triangle, a squared plus b squared is equal to c squared, right? The converse is correct also, all right? If c squared is equal to a squared plus b squared, then it has to be a right triangle, right? The corollaries are, if the angle is an obtuse angle, then c squared is larger than a squared plus b squared. If it's an acute angle, c squared is less than a squared plus b squared. Okay. Let's go to example number 1. See if we can do some examples. Example number 1. Find the value of x. Give your answer in the simplest radical form. So I'm going to give you 6, 4x. Example 1. Daniel. Where are you, Daniel? Daniel, solve for x was. This is the right triangle.
I go 6 squared plus 8 squared.
6 squared plus
I mean, 4 squared.
4 squared. Okay, thank you. 4 squared is equal to
Uh,
x squared, right? So how am I going to solve this? 36 squared. 6 squared is what?
36.
36. 4 squared is 16 x squared. So 52. X is equal to root of 52. Am I done? No? Why not? What can I do? Right? I can take the 4 out. Root 4 is what? 2. Root 13. That would be your final answer, right? Okay. If you wrote this as root 52 and did not do the next step, I would begrudgingly give you full credit in geometry. You come to my honors pre-calc class, not happening. Okay? Okay? Just giving you what my expectations are. Okay? All right. Example, the next one we have, that was A. B as x minus 1, x 5. Okay. So the relationship here, Raquel. Where's Raquel? Raquel, what is the relationship here?
Sorry, I was writing.
That's okay, that's good. Okay, so 5 squared. X minus 1. X minus 1 would be the b, right? So this would be x minus 1 squared. That's going to be equal to the hypotenuse, which is the longest one, which is x squared, right? Okay. So this is our old friend. We did this in algebra, right? X minus 1 squared. So this is 25, obviously, right? X minus 1 is equal to x squared. Okay. 25. Now I go do the distributive law. I get x squared minus x minus x, minus 1 times minus 1 is plus 1, x squared. Right? Or if you were lucky enough, not lucky enough, or if your memory was good enough to remember this, you can immediately say that this is x squared minus 2x plus 1, right? You guys remember that? You guys seen this, the purple one? Have you guys seen this before? No, okay, never mind. Forget that I even said it. Okay, but you do remember how to do the distributive law, correct? All right, so this is okay, right? This is okay. Are we okay with this? All right, so at this point, we can say that x squares cancel out. They have the same one on both sides. 25 plus 1, so I'm going to go at 26 minus 2x is equal to 0. All right. So I'm going to move the 2x over. 26 is equal to 2x. X is equal to 13. Okay, so the book stops here. For you, you should think, okay, well, x was 13. So this is 13. Therefore, this guy is what?
12.
This guy is 12. This is the next famous triplet. Again, 3 integers that satisfy Pythagorean theorem. 5, 12, and 13. 3, 4, 5 was our first one. 5, 12, 13 is our next one, right? Okay, move on to example number 2. To prevent the ladder from shifting, safety experts recommend that the ratio of A to B, where you have a ladder on next to a house, or it looks like something, a building, this is a building. They recommend that A to B, so A to B, 4 to 1. 4 to 1. How far from the base of the wall should you place the foot of a 10-foot ladder? 10-foot ladder. 10-foot ladder here, right? And you're trying to find, so A, you're trying to find how far from the base of the wall should you place it. So you're trying to find this guy here, right? This length here. Okay. So if this is B, what is this? This would be 4 B's, right? Because it has to be 1 to 4, right? The ratio has to be 1 to 4. So if this was B, I can call this 4B. Now all you do is solve for B, right? Using the Pythagorean theorem, right? Okay. McKenna.
So for A, it would be 4b squared.
Okay, 4B squared. Good.
And then for B, it would be x squared.
Oh, B squared, right?
Oh, sorry, b squared.
Okay, and that's going to be equal to
B squared.
10 squared. Nice. So 4B squared is going to be what? 16B squared, right? So I have to square the number and the variable. Plus B squared is equal to 100. So I'm going to have 17B squared is equal to 100. B squared is equal to 100 divided by 17. So B is going to be equal to plus, well, I'm not doing plus or minus, 100 over 17, right? So which is what? Square root of 100 over square root of 17. Square root of 100 is what? 10. Square root of 17. In algebra, You guys were taught not to leave this way, correct? You were taught not to have a radical on the bottom. Okay? I'm going to teach you now, in my classroom, this is perfectly acceptable. You can stop here. Okay? Just a little bit of background. The reason why we didn't do this, we did not want to do this, is because in the olden days, we did not have calculators. If you have your calculator, you just put 17 into the square root and you put the inverse, multiply it by 10, and you're good to go, right? The calculator does this, no problem. There's no reason to really change it into something that looks like this, right? In the olden days, we did not have a calculator. What we did have was slide rules. Okay? In a slide rule, you can do this, but you can't take the reciprocal of it. Okay? You can't do that in a slide rule. And that's the only reason why everybody wanted you to change this to this. Slide rules went out like 50 years ago. We have calculators, so you don't need to change this from this to this. Okay? So you know. Okay, number 3. Example number 3, 362. I find the missing side length. Tell the side lengths for a Pythagorean triple. Okay, Pythagorean triple. So the first one is kind of a trick question. Not necessarily a trick question because it's hard. Because what do we have? 12 and 15. We're trying to find x here, right? So how would I find x? Jackson. Where are you, Jackson?
Okay, 12 squared
12 squared,
and b is 2 squared.
x squared,
No, equals 2 squared and
15 squared. 12 squared is, Jackson? 144. 15 squared is? Thank you, 225. Good job. So, what's the next?
And then you put 144 on the other side.
144 on the other side, so I have to subtract that out.
Yeah,
What do I get?
81.
81. So x is going to be equal to 9. So again, did we find a new triplet? We did, but we kind of didn't. Anybody tell me why we kind of didn't? Although yes, these are integers and they do work. Isn't this kind of the same thing as I just multiplied these by 3, right? So I multiplied the old tried and true triplet just by 3, right? So it's kind of a new one, but it's really not, right? Yeah. All right, B, 15, 9, and then X. So on this one, we're gonna have 15, 9, and we're going to try to find X here. Okay, why are you showing up? Okay, Sarah.
You would do 15 squared
Uh-huh.
plus 9 squared
Uh-huh.
equals x squared.
Okay,
Then
15 squared was what?
225.
9 squared was,
81. And then equals x squared.
which is, what is this? 306 x squared. So x is going to be equal to the square root of that. little trick here. When the three numbers add to a number that is divisible by 9, that number is divisible by 9. So 306 therefore must be divisible by 9. Okay? If I divide this by 9, what do I get? 34. And why is it important that it's divisible by 9? Because 9 is, this is, so that's your answer. Okay? If three numbers, when they add together, they're divisible by 9, they are divisible by 9. If you add the three numbers together and they're divisible by 3, they are also divisible by 3. Right? That only works for 3 and 9. Okay? Don't go trying on something else. Okay? So 123. This is divisible by 3, obviously, right? I added the other, it's 6. 6 is divisible by 3, right? Because if I divide this by 3, I get 41. Okay? Quick little trick. Right? Okay, that was number 3. Example number 4. Tell if the measures can be the side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. Okay, so trying to see if they form a triangle. We've done that before in our previous chapters, right? 8, 11, 13. What needs to happen for them to form a triangle? The two lengths have to be, when you add them together, have to be greater than the other one, right? So I have to check all three of them, right? We have this guy, and this guy. Do they all work? 19, 21, 26, looks like they all work. So this obviously is a triangle. Okay. If this was going to be a right triangle, which one would be the hypotenuse? The hypotenuse is always the longest one, right? It has to be this one, right? So if this was a right triangle, this would be correct. Let's see what happens. What is 13 squared? Thank you. 8 squared? 11 squared? Okay, so if I add these two together, what do I get? I get 185. So obviously this one is larger, which means that the hypotenuse is not long enough to be a right triangle. Therefore, it must be a acute triangle. All right, good work. And B is 5.8, 9.3. And what's it? 15.6. So 5.8 plus 9.3, 15.6. 5.8 plus 15.6, 9.3. 9.3, 15.6, 5.8. Oh, this is what? This is 15.1, right? So immediately we get a reject, right? Immediately, this does not work. Therefore, there is no triangle. You cannot form a triangle with these three lengths. So you can't qualify something you can't do, right? You can't tell me if it's an obtuse or whatever, because it's not a triangle. All right, we're done. We are done.